A block is sliding across some ice. It travels a distance of 16 meters before coming to rest from an initial speed of 6 meters per second. Find the coefficient of friction between the block and the ice. Now, before you do any sort of mechanics problem, it's good to draw a clear diagram. So here is my ice and here's my block. We don't know the mass of the block, so we'll just say that is m kilograms. It has an initial speed of 6 meters per second. It's going to travel 16 meters and end up at rest, so the final velocity will be 0 meters per second. What we don't know is the acceleration, but we can use the Suvat equation. So finding the acceleration, so using the Suvat equation, v squared is equal to u squared plus 2as. So the initial velocity u is 6, the final velocity v is 0, and the displacement is 16 meters. So we're going to have that 0 squared is equal to 6 squared plus 2a times 16. 6 squared is 36, and then so when we take it over here it becomes minus 36, be careful with signs, is equal to 32a. Dividing by 32, we're going to get that a will cancel down to minus 9 over 8 meters per second squared. Now, if we now consider the forces acting on the block, so the forces acting on the block are the weight acting downwards, which is mg. We don't know the mass. There is a normal reaction R, and as it's moving this way, if it's sliding across, there is a frictional force acting against the direction of the motion, which we're going to call F. So using Newton's second law, we're going to take this way as positive, so F will be minus F. Minus F will be equal to the mass times the acceleration. We can say that minus mu r is equal to m times a, because friction is equal to mu times the normal reaction. And if we resolve forces this way, we can say that r is equal to mg, as there's no movement this way. R minus mg is equal to 0, so it means that r is equal to mg. So we'll replace r here with mg. We're going to get minus mu mg is equal to m minus 9 over 8. Now the m's here will cancel out, so that's good. So we're going to end up with minus mu g is equal to minus 9 over 8. The minus signs will also cancel out, giving us mu g is equal to 9 over 8. Dividing by g, we're going to get that mu is 9 over 8 times g. Now use the fraction button on your calculator, and g is 9.8 meters per second squared. That will give you 0.1147, and round that off to 3 significant figures. The coefficient of friction will be 0.115 to 3 significant figures. So this has been a video to show you how to calculate the coefficient of friction given a block sliding across some ice and the initial velocity and the distance travelled until it comes to rest. So I hope you've understood, and I thank you very much for watching.